The next concept is a tensile and compressive strain. So what is a tensile strain? The strain which is induced due to the application of tensile load is nothing but a tensile strain. So here, due to the application of tensile load P, there is a change in length delta L and its original length is L. So as per the definition of strain, change in length by original length is nothing but a strain. But in case of a tensile load, there is extension of the bar. Therefore, we can consider the change in length as an extension and original length as L. So extension by original length is nothing but delta L by L. Coming to the compressive strain. The compressive strain is nothing but the strain which is induced due to the application of compressive load. So due to the application of this compressive load, there is a decrease in length of the bar. The decrease in length is delta L, or the change in length is delta L. Original length is L. Therefore, the compressive strain can also be defined as the shortening of bar by original length, because we are applying the compressive load. Therefore, the shortening of the bar takes place. So therefore, epsilon is equals to delta L by L. So to explain the shear strain concept, let us consider a element ABCD which is applied by a shear force on the surface AB and DC in the opposite direction. So due to the application of this shear force, there is a change in shape of the element on the face DC takes place to the new position C dash and D dash by an angle phi. Therefore, the shear strain can be defined as tan phi. So if we take the trigonometric function to the triangle AD dash D, tan phi is equals to opposite side by adjacent side, that is D dash DD dash by AD, which is nothing but a shear strain. So if the angle is very small, if phi is very small, tan phi is approximately equals to phi. Therefore, phi is equals to DD dash by AD, which is nothing but a shear strain. The longitudinal strain or linear strain is nothing but the strain which is induced along the linear direction of the bar is nothing but a linear strain or longitudinal strain. So here, due to the application of the load F or the load P, there is a change in dimension along the linear direction. The change in direction is delta and its original length is L. Therefore, the linear strain can be defined as the change in length along the linear direction to the original length. So the change in length is delta, original length is L. Next one is a lateral strain or transverse strain. So here, transverse strain is nothing but the strain which is induced along the transverse direction is nothing but a transverse strain. So in this case, along the transverse direction, there is a change in diameter. Therefore, lateral strain can be defined as change in diameter in lateral direction to the original diameter. The change in diameter is capital D minus small d divided by original diameter is capital D. So due to the application of the force along the linear direction, there is a combination of linear strain as well as lateral strain takes place. So the next one is Poisson's ratio. So the Poisson's ratio is defined as the ratio of lateral strain to the linear strain, and it is denoted by a Greek letter mu. So Poisson's ratio is equals to lateral strain by linear strain. So the lateral strain, from the previous concepts, lateral strain is nothing but capital D minus small d by capital D, that is change in diameter to the original diameter. Then linear strain is nothing but change in length to the original length.